Today, I'm going to be talking about one of the essential tools that has been used to understand the spread of infectious disease outbreaks, such as the current outbreak of COVID-19 that we're seeing in the world today. I'm going to be talking to you about models, mathematical, statistical, and economic models. Models are simply a simplification of a very complex object. In this case, the complex object is the real world. 8 billion people in the world, all interacting with each other, getting infected, interacting with the pathogen, the COVID-19 virus, and interacting with their environment. This is far too complicated for us to understand just with our unaided minds. So mathematical, statistical, and economic models help to simplify this by setting up relationships between different aspects of the world. Models have been an essential part of understanding and responding to the outbreak of COVID-19. At the beginning, models were used to understand what was happening in Wuhan, where the outbreak first started, and how infection spread from Wuhan to other parts of China and other parts of the world. Now that we're having outbreaks in many parts of the world, and epidemics in many parts of the world, the models have been used to understand some of the key features of the virus that we need to know in order to know how to respond to it. For instance, how long are people infected? How many people might they infect when they get infected? Can people infect other people even before they show symptoms? That's essential to understand, to know whether we can stop people from transmitting to other people by actually finding them quickly and making sure that they're isolated before they spread to other people. We're also using models to understand how large the epidemics will be in different parts of the world and whether we have the healthcare resources that we need in order to make sure that people have enough space in hospitals, enough space in intensive care units to make sure they get the treatment that they need. The rate at which the disease spread is influenced by how often people come in contact with one another. And obviously, within very closed environments, such as on a cruise ship or in prison, there's a lot more close contact between individuals. And these are some of the places where we've seen big outbreaks of COVID-19. So the spread of the virus can also be influenced by what's happening in the country or in the location. So for instance, if schools are closed, or if workplaces are shut and people start working from home, or if people stop traveling or stop going out, then this will reduce the number of contacts people have with other people, and that will slow down infectious disease spread. Countries with COVID-19 cases report the number of cases that they've detected, but these numbers are probably much less than the actual number of cases that are in the country, because many people who are sick have mild symptoms or maybe no symptoms at all, and therefore they don't report themselves as being sick to be tested for COVID-19. As a result, modelers have to look for other hints about the true number of cases. For instance, they look at the speed at which these reported cases are increasing in order to understand how fast the virus is spreading. Or they look at other outcomes which might be better recorded, like the number of deaths due to COVID-19, or the number of cases that are picked up because people leave the country and go to another country. So we put all these clues together to try to get a good understanding. And to do that, one really important number we try to estimate is R0. And if we know this number, R0, and we know the length of time that someone is infected, then we can have a good guess as to how fast the virus will spread. We also want to know the number of deaths, and we have to be careful when we look at the number of deaths that is being reported, because deaths are a lagging indicator. So you might be sick for a week or 2 weeks before you'll die. And therefore, the number of deaths we see today probably reflects what's happening with the epidemic about 1 or 2 weeks ago, rather than what's happening now. So we have to be careful when we calculate the ratio between cases and deaths, what we call the case fatality ratio, to take into account the fact that actually there is this lag between cases and deaths.